Hey, welcome back to another junior geometry video. We're just doing a couple of quick videos on parallel lines at the moment, and this video is about alternate angles on parallel lines. Okay, so here's the geometric rule. Alternate angles on parallel lines are equal. Alternate angles on parallel lines are equal. Now pop your eyes down to the diagram below. You can see we've got two parallel lines and a line through them. That line through them is called the transversal, and you can see a pair of alternate angles on either side of the transversal, and they're equal. So let's get out of here and get into GeoGebra and show you what is this all about. So we've got a pair of parallel lines. I'll just bring that back down here. So we've got a pair of parallel lines. No matter what I do, they are going to stay the same distance apart and never meet. So let me add in my transversal. Transversal is a line that cuts through two lines. Here's my transversal from E to F, and it cuts through at points J and K, right? Okay, so let me add in my alternate angles. Here is my first alternate angle. Now this angle here down here at 34 degrees is the same as this angle up here at 34. Notice they're on opposite sides of this transversal line. They're on opposite. That's why we use the word alternate, because alternate means on opposite. So this angle down here, which we would call, what would we call this angle? We would call it BJK. BJK is equal to this angle up here, which is CKJ. So those two are equal because they're alternate. Now, alternate angles have a nickname called Z angles. I hope you can see I've colored in green what we mean by the Z. They're often nicknamed Z angles. Right, well, there is another alternate angle pair on this diagram. I'll show you the other pair, and if I can go, boom, there is the other pair. These two on the other side are also, let me just move that out of the way, these two are also alternate angles, and they are equal as well. All right, so it doesn't matter where I move my transversal, you can see that those alternate angles will stay the same. They are equal. Now I know you're probably going to argue a little bit that this doesn't really look like a Z, it's more like an S, but we still give them the name Z angles. Can I just give you a really quick proof as to why they are equal? I'll show you, move that out of the way. Let's go back to the first pair of alternate angles and let's bring in our corresponding angle. All right, if it comes up, taking a bit while to load. Come on, no, there she is there. Right, this angle up here, this 35 and this 35 are all corresponding. Sorry, I said alternate, I think I said. So these two are corresponding. We learnt that in the last video. These two are corresponding. And then you should know that these two here are vertically opposite. So that's why this angle is also 35. All right, let's head back to the PowerPoint and let's get back into a quick example to wrap up. So example one, we're going to determine the size of angle EGH, which is this red angle up here. This red angle is angle EGH. And hopefully you've figured out very quickly that angle EGH or EGH, whichever angle way you like to write it, is equal to 98 because it's an alternate angle with this 98 down here. Remember, with our geometric reasoning rules, you can't just write down an answer. You must provide a geometric reason, and the geometric reason is alternate angles, parallel lines. You don't have to say are equal. You can if you want, but you just need to say alternate angles, parallel lines. Remember the shortcut for all of these. This is the shortcut for alternate angles. We abbreviate alternate to alt. We use the angle sign, and then we use those two slanted slashes for parallel lines. All right, cool. Hey, thanks so much for listening in.